Hello, grade 8. In this video, we're going to talk about and learn a bit more about transformations. Now, what we're doing in this video is really putting together three things that we've already talked about. So we have reflection, rotation, and translation. And when we put all three of those together, we call those three things transformations. Just as a bit of a reminder, reflection is when we flip an object or a point. Rotation is when we spin an object or a point around a central spot. And translation is simply a moving of the point or the shape to a new location. So let's talk about different translations or transformations that we can do. And what we're going to also take a look at is that we can combine different transformations in order to make something a bit more complex. So here we have two translations put together. We've called them T1 or transformation 1 and T2 or transformation 2. And whatever object we have, we're going to assume that it's going to go through T1 first and then T2 second. So T1, the transformation 1 that the shape or object is going to go through first is going to be a reflection in the x-axis. So just as a reminder, the x-axis is the horizontal line, the one that goes left and right. So it's going to reflect or flip in that line. T2 is going to be a rotation or a spin 90 degrees, which if you remember from our last video is a quarter turn clockwise around the origin. Remember that the center point here, where we have x as 0 and y as 0, we call that the origin. And so in this first example, the transformations, it's going to reflect in the x-axis first, and after that, we take that reflected object and then rotate that reflected object 90 degrees clockwise around the origin. In this example, we're reversing that. So in other words, the object that we have, we're going to first rotate 90 degrees clockwise around the origin and then reflect that rotated object in the x-axis. So it's important for us to take a look at the order that we are doing transformations in when we have multiple different types of transformations. Let's take a look at a particular example. We have two, and these are the examples from our textbook that we're going to work through. So if you want to see them written down, they're also in PDF form on this section in Google Classroom as well. So the first question right here says the diagram shows three triangles. We have triangle ABC, we have an image ABC, and we have another image, ABC. We show they're different because this one has one tick or one line beside the letters, and this one has two. The first question says a transformation V, and they've just called it V. You could use any letter or any variable to refer to the transformation. Here we use T, here we use V. Maps triangle ABC onto triangle ABC, this triangle here. And another transformation, W, maps this ABC onto this new image ABC. So the question says, describe fully the transformations V and W. So let's take a look at V. That's getting us from this object to this object here. And we're going to see, is that a reflection, a rotation, or a translation? So let's just start at the bottom here, translation. Is it just a move from this spot to this spot? I'll give you a second to think about it. And the answer is no, it's not just a move because something's a little bit different. And the thing that's different is that this is a mirrored version or a flipped version of the first triangle. So we know that transformation V is a reflection, but now we have to figure out some of the extra bits of information. What was the mirror line or the reflection line that this flipped over top of? And to find that, we really just need to find the exact middle line between the two objects. So in that case, that's this middle line right here. And if you remember from our other videos, that we call the y-axis. So V is a reflection in the y-axis. Okay, now let's take a look at transformation W. Transformation W is going from this shape to this shape here. So first, is it a translation? Did it just simply move? No, because it's in a different orientation. It doesn't look exactly like this standing up with C at the top, A down here, B over here. So it wasn't just a move. Is it a reflection? Is it a flipped version of it? Well, not quite. For it to be a flipped version, it would have to mirror itself. So C would have to be either right on the bottom, or A would have to be on the other side, like we had over here. And so the other option, is it a rotation or a spin? And it is. So if we think about this object, this has rotated to the right 90 degrees. And the next point is to see, where did it rotate around? This might be a little bit trickier, but let's take point B. It's equal distance from here to here at a 90-degree angle clockwise. So we would say that translation or transformation W is a rotation 90 degrees clockwise around the origin, which is just a fancy term for this middle point. So that's example 6. That's describing a particular transformation, or two transformations here, on the triangle ABC. We had transformation V and transformation W that caused us to change the location of this triangle. I do want to note as well, and we talked about this at the beginning of this unit, that each of these triangles are congruent to each other. If you remember from our first video, congruency means that it is the exact same size and shape, or the side lengths are the same size, and all the angles are the same size as well. Let's take a look now at example 7. Example 7 I have drawn out here. It says plot and label triangle PQR, and then it tells you where the vertices are, or where the corners or points are of this triangle, but I've already located those for you. So here we have PQR. It's this middle triangle here. And then it says, and there's going to be a line x equals 3. X equals 3 just means that wherever x is 3, 1, 2, 3 on the x-axis, we're going to draw a line there, and we're going to use that line a little bit later on. This is our y-axis. It then says the transformation F is a reflection in the line x equals 3. So we're going to do our first transformation. It's going to be a reflection. This time, though, we're not reflecting in the x-axis or the y-axis. We're reflecting in a different mirror line. And the mirror line that we are reflecting in is x equals 3. So this triangle is going to flip over this line, and we're going to get a new triangle, the image of triangle PQR. So you can look back on the previous video about how to do that, but basically we want to find the exact distance that each point is from the line, perpendicular to the line, so the exact opposite direction, and then go that much further past it. We talked about the term an equidistance line. So that would be how we would mirror 1, 2, 3 spots away, 1, 2, 3 spots, and we get our point here. 1, 2 spots, 1, 2 spots, and this one's right on the line, so it doesn't actually change. It doesn't actually move. Now let's take a look at the second piece. It then says so this is transformation F right here. And then it says the transformation T is a translation of -6 units in the x direction. So now that we've done translation F, translation T, or now that we've done transformation F, translation T has us take this new shape and move it -6 in the x, or slide it 6 spots this way. So point P is now 1, 2, 3, 4, 5, 6 away. Point Q is 1, 2, 3, 4, 5, 6 away. And point R is 1, 2, 3, 4, 5, 6 away as well. And so part A in that example says to plot the image of PQR under first translation F, which we already did, and then second translation TF. Translation TF would be a little bit different because we would do T first, which is a moving of -6 in the x direction. So 1, 2, 3, 4, 5, 6. This would be our new point Q, our point P, and then our point R would actually be down over here. And then we do a reflection in the x direction. So this would give us an image that would be way over here as we reflect that, because even point P here is 1, 2, 3, 4, 5, 6 spots away. 1, 2, 3, 4, 5, 6 spots away. And so our reflection would look a little bit like that when we go through translation T and then translation F. Part B asks us to describe a single transformation that will map PQR onto triangle P2Q2R2, which is this one here. So we figured out how to get to here. We figured out how to get from here to here. But now they're saying describe one move that can get us from this triangle right away to this triangle. Not two moves, but just one. And so we have to see, is that a translation? Nope, because they're in different spots, the P, Q, and the R. Is it a rotation? Did it spin? Well, not quite either, and we could try a couple of options to see that that's not what it is. Is it a mirrored version of it? And yes, it is. And what's the line that it reflected in? And that's here, the y-axis. So a single transformation that would map triangle PQR onto triangle P2Q2R2 would be a reflection in the y-axis. So this is what we have for transformations. There's not a lot of new information that we're learning here, but it is putting everything that we've learned so far all into one spot. And so we've talked about congruency. We've talked about how two figures are congruent if there is a combination of reflections, translation, and/or rotation, which moves one figure onto the other. And in our next video, we're going to take a look at a couple of other key examples that we've studied that can help us to understand that when two triangles can be shown to be congruent. There's a couple of laws that we're going to go over involving angles and sides.